Hello and welcome back. In this video we're going to be going over how to complete the square. Completing the square is basically focused on converting the standard form of a quadratic equation to the vertex form of a quadratic equation. We will find that the vertex form of a quadratic equation is very useful for sketching a parabola as it gives us the vertex. So why don't we begin with this example. In this example, we have a quadratic equation in standard form, and we're going to try to use completing the square to convert it to vertex form. So the first thing that we are going to do is place brackets around the first two terms. Once we do that, we are going to look at the number in front of the x, which I will color code as orange. We are going to take that number and divide it by 2 and then square it. So in this case, we have 6, so we are going to do 6 divided by 2 is equal to 3, and then we are going to square 3 to get 9. Okay, so we have divided 6 by 2 and then squared it. Once we have that value, we are going to both add and subtract it to the expression inside of the brackets. So we will have plus 9 and minus 9. The next thing we are going to do is carry the negative 9 outside of the brackets. That will give us x squared minus 6x plus 9 minus 9 plus 14. And if you're not sure why we are able to do this, it's because, if you think about it, these brackets weren't even there to begin with, right? We placed them because we knew it was going to give us an easier time to try and complete the square. So it doesn't really matter whether the negative 9 is behind the bracket or in front of the bracket. All the steps that we are doing is essentially to make it easier for us to convert to a vertex form, which, as we will see later on, is very useful for sketching a parabola. So we've carried out that negative 9. We know that negative 9 plus 14 is 5, so we can simplify that as plus 5. And we're basically left with a simple trinomial plus 5. And what we're going to do is factor that simple trinomial. So we want two numbers that add up to negative 6 and multiply to 9. We know that negative 3 and negative 3 add up to negative 6. And we know that negative 3 times negative 3 is equal to 9. So we know that the two numbers that we are looking for are negative 3 and negative 3. We can therefore write x squared minus 6x plus 9 in factored form as x minus 3 times x minus 3. So overall we have x minus 3 times x minus 3 plus 5. We know that x minus 3 times x minus 3 is x minus 3 squared. So we can rewrite it like that. And we have essentially converted the equation in standard form to the equation in vertex form. And I will guarantee you that every time you apply this technique using the methods that we have established, you will always be able to essentially merge the two factors to get something squared. It's simply because we designed these steps so that we would end up getting a specific equation that would work well for vertex form. So to summarize, we have that y is equal to x squared minus 6x plus 14, which is the equation that we began with is in standard form, and by completing the square we have established that y is equal to x minus 3 squared plus 5, which is the equation in vertex form. Okay, and I told you that vertex form is very useful for sketching the parabola. That is because it gives us the most useful point on the graph, which is the vertex. In this case, our vertex is 3 and 5. So the x value of the vertex is 3 and the y value of the vertex is 5. Okay, so I can add some color coding to help you better make that connection. You basically take the value inside the x brackets and that becomes the x value of your vertex, noting that you always have to flip the sign. So because we have negative 3, that becomes positive 3, and then the value outside of the brackets is always the y value of the vertex, and in that case we do not flip the sign, so plus 5 is plus 5 for the y coordinate of the vertex. So why don't we do another example? In this example we have another standard form of a quadratic equation, and we're basically going to follow the exact same steps again. So once again, the first thing we'll do is place brackets around the first two terms. We will then color code the number in front of the x, which is 4, and we will both divide 4 by 2 and then square it. So 4 divided by 2 is 2, and 2 squared is equal to 4. So we know that we have to both add and subtract 4 from the expression in the brackets. We can then carry the negative 4 outside of the brackets. We know that negative 4 minus 3 is equal to negative 7, so we can simplify the expression as follows. And once again, we want to factor this simple trinomial. So we need two numbers that add up to 4 and multiply to 4. We know that 2 plus 2 is equal to 4 and 2 times 2 is equal to 4. So we know that the two numbers we are looking for are 2 and 2. So we can rewrite that equation, that simple trinomial, as x plus 2 times x plus 2 for a factored form. And then we know that x plus 2 times x plus 2 is x plus 2 squared. So once again we have established our equation for the vertex form, knowing that if we apply these steps in completing the square, we would have something squared in the vertex form. So once again, the equation that we began with was in standard form, and the equation we ended with was in vertex form. From the equation, we know that the vertex is negative 2 and negative 7, and I will again add the color coding to help you better make that connection. So again, we always flip the sign for the value inside of the bracket, and again, the value inside of the brackets is the x-coordinate of the vertex. We make sure to flip the sign so that 2 becomes negative 2. And the value outside of the brackets is the y-coordinate of the vertex, so we have negative 7. Again, for the y-coordinate, we do not flip the sign, so because we have minus 7, we have negative 7 for the y-coordinate of the vertex. So that is all I wanted to go over for this video. In the next video, we will do completing the square with complex trinomials, but for now, as always, thanks for watching.